This is Mr. Beck Does Your Homework. This is AP Physics, Homework 8.2, question number 10. 1 mole of an ideal gas at 0 degrees Celsius is held at a constant volume of 97 liters. Find the change in pressure if the temperature increases by 64 degrees Celsius. Answer in units of atmospheres. Well, I've got PV equals nRT. If I want a delta P, then it's going to relate to a delta T. So really, I've got my initial pressure is going to be nRT over V1, so this is all 1. And my new pressure is going to be nRT2 over V2. So my delta P is going to be my P2 minus my P1. So that's going to be nRT2 over V2 minus nRT1 over V1. To make this a little mathematically simpler, I can factor out nR. So I've got my delta P, my change in pressure, is going to be nR times T2 over V2 minus T1 over V1. But since my volume is constant, then I can also pull that volume out of this equation. So I can say that my delta P is going to be nR over V times T2 minus T1. That makes it really easy. So now N is in moles of gas, great, 1 mole. R is 8.31. My volume, this has 97 liters. I'm going to have to convert that into cubic meters. So let's see. N equals 1 mole. That's good. The temperature is 0 degrees Celsius. So my temperature is going to be 0 plus 273. For me, that's going to be 273 Kelvin. That's my initial temperature. What else do I need? R is 8.31. My T2 is going to be 64 plus 273, so that's going to be my T2. And my volume is given as 97 liters. And 97 liters, remember there are 1,000 liters in 1 cubic meter, so that's going to be 0.097 cubic meters. So now I know N, I know R, I know V, I know T2, I know T1. I can go and solve for delta P. For this one, you might notice, no, that's fine. Oh, that'll give you your delta P, but that'll give you your delta P in kPAs. So once you get your delta P in kPa, sorry, in pascals actually, in actual pascals, you know that there are 101,300 pascals is the same as 1 atmosphere. So you take your answer, you divide it by 101,300, and that's going to give you your answer in atmospheres.